Hi everyone, this would be the third attempt of me solving the question 320, get smallest element in BST. So, okay, let's just directly go to our test cases. Test case 1, we have 3, 9, 20, 15, 7, 9, 3, 15, 20, 7. And let me draw the 3. Hold on with me. Okay, let me write down also the. Okay, let's do it step by step. First example 3, 9, 20, 15, 17. Second example. We have 3, 1, 2, 4, and 1, 2, 3, 4. The clock looks like 3, 1, 2, 4. Okay. So now we know that everything on the left of. Okay, so let me just write down my findings so far. So everything. Okay, let me make it clear here. So preorder is root, then left v3, and then the right v3. However, on Inorder, it will be the left v3, the root, and then the right v3. Okay, so now we see that what do we see here? The right v3 9, 3, 15, 10. Okay, so it's not just the okay, let me put it this way. Preorder is a starting from root, and then it print the preorder of left v3, and then the preorder of the right v3. In order, it will print out in order of left v3, and then the right v3 is also printing the in order. Okay, so it's like a recursive order. So what can we tell from here? You can see that still in an in order, everything before the root is the left v3. It belongs to the left v3. Alright, so I think okay, so from this we can find that in order everything that before the root belongs to the left B3, so we can count how many elements of it is in the left one, and then how many of them is on the right one. And then from the preorder, we can find out the root of the left B3 and the right B3, which is the first element. So let me write this down. Preorder this would be the root. And this would be root top left. Then this would be the root right, and then the top. Okay. Okay, so from here, I think we can build the tree again from the root. So we pick out the root, create the node, and then from the Inorder, we tell whether there is a left and right. If there is a left, then we create the left, and also the same for the right. And then now we are gonna continue from there. You're gonna check again for true. Is there something on the left and there's something on the right? And so on and so on. Okay. If that is the case, I think we can still use a similar logic as the previous one, except that the root will not be using that kind of ordering. This is getting interesting, I think. Okay, so I'm thinking of using the examples there. So for example 1, if we have 3, 9, 20, 15, and 7. 9, 3, 15, 20, and 7. First we build the 3, then there is 9, and then right hand side have 20. 20, 15, 7. So first example honestly is a bad example because it doesn't bring up the special cases. Like the second one here, actually let me call it example number 10. Okay, so we have 3 there, and then 1 and 4, and then we build the 2. Okay, right, I think we could use a similar logic as to the previous submission. And in here, let's see how you're gonna do this. I think I'm gonna create another function for this so I can do it recursively. So I'm gonna call it build. Let's see. And then you want to build at I. Okay, they got it now. So define build at I. If I in visited, actually I don't need to do this. So root equals 3 not preorder at I. Okay, now I'm gonna check if in order of index of root dot 12 minus 1 not in visited. Still quite hard to do this because I need to keep track of the right and left boundary. Okay, so how about this? Left and right. Okay. I mean, how do I know how much to jump? Can I just build the left subtree first? Yeah, I think it makes sense to build the left subtree first. But how am I gonna do that? So everything that in a pre-order, I'm gonna keep getting the root and the root and the root and so on. So if I build it recursively, then what I can do is that I can keep adding it into my visited. So if I build 3, in example 10, if I build 3, and then I know that there is something on the left, so I build the left, started at 1, 1 has no left, so it continues to the right. The right has 2, now 2 is visited, then we go back. Okay, now this looks much more easier. So what I'm gonna do is I'm gonna call a build I, create the root, and then visit it. Visit.add root.form. If order is not visited, then root.left equals build of I plus 1. Okay. Now if in order of with I plus 1 blah blah blah, this is plus 1, I plus 1 root dot right equals build of I. It's going to work. Seems quite funny, yeah? So I'm thinking there's a better way to do this. If I keep a while, Okay, so let me try out the examples then. So we have 3, 9, 20, 15, 7. First of all, I click 3, and then 9 is not visited, so create the left. The left would be 9. Now 9 has nothing. Now to the right, right is 20, 15, and 7. Now 2, we have 3. Then there is 1. Now 1 has a right at 2. Now coming back, it will be 4. So this could work. Now let me try it out in the code again. Hopefully this time we got it right. I'm gonna copy some essential things from there. Visited index in this part. Yep. And can I do it in a while loop? I need to use a recursion there. Define verb for. Can I use a for there? So root equals 3 node of 4 visited at node. So if preorder and you can copy from here and this all. I'm gonna build sorry dot left equals build preorder dot top left. Same for the right. Then in the end we return the root. Return to preorder dot top left. Okay. And that's not, this is not. Yep, try to submit it. Hopefully you got it right. Oh, thank God, you got it right. Yeah. So I finally got the idea after 3 attempts here. Let's look at submissions from other people to learn from that more. ATTEMPT-3. Okay, let's look at this. ATTEMPT-3, left and right. Left and right in order. Investment of -1. I think this is more or less my idea too, except that it doesn't have any complicated if. Yeah. And curious how it's gonna make sure that it doesn't go out of bounds. Okay. I think more or less everyone is kind of doing the same thing. I guess so. Yeah, I see a lot of people using left and right. Then it's using DFS. How does it work? Okay, let me pick out one that is kind of simple to me. Okay, let's look at this one. So we have a map in order. Okay, so that's my index, same as what I see, same as what I do. Then binary 3, start and 3 top left, map. Binary 3 mid. So it works on the left, then it works on the right. Okay. Yeah, I think this kind of makes sense too. But here we keep on calling the and passing the start and end. Yeah, so it works, I guess. Yeah, I think this is much more simple than what I did. But yeah, thanks everyone. I think I'm gonna stop here. Because, but I'm honestly relieved that I could finally get the optimal solution. So yeah, thank you everyone.